Hello, and welcome to Kubernetes security in a highly regulated environment. My name is Kenichi Shibata, and I work for Compare the Market as a cloud solutions architect. Compare the Market is one of the UK's leading market comparison website and specializes in insurance market comparison. So before we begin, let's start by defining what is a highly regulated environment. A highly regulated environment is basically any environment that is guaranteed a level of quality. It's not as scary as it sounds. Rather, it ensures a level of quality that would ultimately help our customers. So when we talk about highly regulated environments, we usually refer to external standards and regulations. Regulations and standards such as NIST CSF framework, cybersecurity framework, CIS or Center for Internet Security, HIPAA, PCI DSS, FIPS, ISO 27001, and most of the time we refer to industries such as healthcare, finance, or government. So let's say, for example, you're tasked to deliver a highly secure Kubernetes environment platform as a service, and your job is to ensure you comply with one or more or all of these standards such as CIS level 1, having an ISCORP 3.0, being PCI compliant and able to process credit card transactions, being a government agency and therefore you need to comply with FIPS, or processing personal health data and you need to be able to comply to HIPAA. So what's the difference between a Kubernetes environment and a VM virtual machine environment? So the difference mainly lies in the abstractions that Kubernetes brings. So when you create an environment that is Kubernetes or container-based, you add an additional abstraction such as container orchestration, container runtime, container registry and supply chain, and then different parts of the OS. This mostly relies on you being able to manage this, and that's the main difference between a VM-based versus a container-based environment. So if there is such a difference, then the question is, how do you measure compliance to standards with those additional abstractions? So mainly, how do you measure this? In NIST, for example, you're asked to have a score of 3.0. In PCI DSS, you need to be compliant in order to accept credit card payments. You need to be CIS hardened for level 1. For example, if you're running Ubuntu, you need to be CIS hardened level 1 for Ubuntu OS. Or let's say CIS hardened for container images. So the main point here is the consistency of getting these measurements. For example, StockCrux offers a full end-to-end platform that allows you to do the compliance measurement. That's one good example, but also AWS allows you to do the same using AWS config and conformance packs. Or you can do it yourself. But the main key here is the measurement should always be consistent and replicatable. Problem with doing things manually is it's hard to replicate how you did the compliance measurement over and over again. So if you can build the compliance and you can measure them, if you can build the compliance measurement and then you can understand them, then the next question becomes, okay, how do you build a good baseline? So our goal in this today's talk is to provide a very opinionated way to build a compliance baseline to start your compliance journey. This is not an end all and be all. If you follow all of this, you're compliant, but rather here are things you have to consider first before you begin, or rather here are some really good pointers to you where you can start. So there are many things you have to consider, and like you see the jumble of words in the screen, all of these are valid. However, it really becomes necessary for you to make sure that you organize this and make sure that you have them working in priority. And today, my opinion is essentially to give you what a good priority order of what you should be working on. So based on the layers earlier that was introduced in the abstraction, here's how I would divide the previous slide and put them into the priority order. The most important thing obviously is orchestration, Kubernetes orchestration. The ability to enforce your policy becomes really important, but we will go through all of this one by one at a time. So orchestration, runtime, supply chain, as well as the platform itself, meaning mostly the hardening of operating system, circuits management, and authentication. So today we will do a whistle-stop tour about all of this, and if we can complete it on time, we will do a very short supply chain video demo. So policy gates. Policy gates is the ability to enforce policy. So let's say you have the policy to only allow certain all container images to be pulled from your own private registry. In this example, on the image on the right, we're only allowing images to be pulled from the ECR private registry of the accounts here 1, 2, 3, 4, 5, 6 in AWS. So that means that if you create an image or try to run an image that's not from that ECR registry, then it should reject it. And this is actually written using gatekeeper. So you build a gatekeeper template on top of this, and then you enforce it using the constraint, which is this. So one thing you have to bear in mind why we're doing it this way is pod security policy is being deprecated, and therefore you need the ability to enforce policies but not rely on pod security policies in the future. So a really good project that allows us to do this in CNCF is the OPA, or Open Policy Agent. And Gatekeeper, which is the example that we're looking at, is one of the ways you can enforce OPA in your environment. Another one is Kyverno. So let's say I try to run a Docker Nginx container in this container. I do kubectl apply -f, and then I apply that. And if you have a policy and it's being enforced, then you can see on the image below that it says it has an invalid image repo, and it only allows you to run images from the 0, 1, 2, 3, 4, 5, 6 ECR. And that's a really good way you can implement your company policies against your Kubernetes cluster. Another thing we have to keep in mind is the authorization and the authentication in Kubernetes. But why am I referring to RBAC testing first and not the authentication? Well, the simple answer is users in Kubernetes are generated on the fly, meaning as long as you have a valid certificate that's being checked against the Kubernetes CA, then you're a valid user. And therefore, it becomes quite difficult for you to test authentication. And you need to do authentication separately from the cluster. What does that mean? It means that Kubernetes doesn't have the native resource user. It does, it only generates it on the fly, only if the certificate is valid. So in the example on the right-hand side, the images, I tried to create a role called example role. The example role should be able to get, watch, and list pods. I tried to bind it to a user called example user, but this example user actually doesn't exist anywhere. It's created on the fly by the role binding because I binded it there. And therefore, example user should now be able to get, watch, and list pods. So if you can create RBAC, or role-based access control, then it becomes really important for you not just to enforce it, but also to test it. How do you test it? Kubernetes allows you to test it using kubeauth command line function. kubectl auth can I gives you a simple yes or no statement based on what you're asking it to do. For example, in this case, I'm asking if example user can create a pod, and it answers me with a simple no. But can I list a pod, or can I get a pod? Sorry, and yes, it can allow you to list a pod. But this is just one step in the process. What you need to do is to test it. So what's the best way to test bash script if you're running as bash scripts? Let's use bats. So bats allows you to run bash scripts. In this case, I'm just running kubectl. Can I get pods as example user using my namespace? If the status exits with 0, that means it's a true T statement, and the output is yes, then I just pass the test. And I can do the same for both for anything that I want to test in the RBAC. So in this case, I run 3 other tests as well. But in theory, you should be testing everything. Another thing you have to keep in mind is the SIM, or the security incident management. Security information management. So that means the events and the logging side of Kubernetes. This tries to answer a simple question: is how do you do forensics? That's the simple question. So in Kubernetes, you have events, and then you have audit logs. There are also additional logs like application and cluster logs, but mostly you're concerned about Kubernetes API, and therefore events and audit logs are of primary importance. How do you get events in Kubernetes? Simple. You just run kubectl get events. The problem with doing this is it's not persisted very long. By default, if you're running kops, it's persisted by 1 hour. If you're running EKS, it's persisted around 5 to 6 hours, but that's it. So if somebody runs an Ethereum miner, like you see on the right-hand side, 6 hours from now or 7 hours from now, nobody would be able to figure that out, who did that, why, and how, and because the events would be gone. So you need to be able to export these events into an aggregator. Below this, you can see I'm running Elasticsearch, and I'm just exporting all those events on the Elasticsearch. What I did is I used an application called Events Exporter by Opsgenie. Another thing is the audit logs. Audit logs is actually of primary importance when you're dealing with SIEM. And the reason why is it will contain all of the Kubernetes API requests and responses that's ever sent to the API server. Everything in Kubernetes eventually ends up in the API server. Any action that needs to happen is being requested and responded by the API server. It's an eventually consistent model, but that means that everything goes through the API server. So the audit logs essentially is an audit of everything that happened in API server. But that means that there's going to be a lot of logs, and therefore you need to pick and choose which one you need. On the very right-hand side, you can see there is a Kubernetes resource called policy. And then you can specify which policy, which Kubernetes event logs you want to be logged in the policy. And then what you can do is you can create an audit sync that takes this policy and then syncs it somewhere. In this case, I put the audit sync in Sematext. Sematext.com has a full managed audit logs capability. So you can see there's a dashboard on the left-hand side, and that processes and aggregates the logs. And then you can do alerting on top of this and the events, and then you can correlate them as well and change the SIEM into a CM, which is really good for forensics and correlating events and audits. So audits are your historical logs, while events are your real-time logs if you do SIEM properly. Another thing you have to keep in mind on the orchestration side is vulnerability management. Vulnerability management allows you to track each vulnerabilities that comes inside your clusters or your platform. So you can do it in 2 ways. You can self-assess all those vulnerabilities and put them into a ticketing system, and then do the analysis, do the CBS calculation, using the CBSS calculator for each one of those vulnerabilities, but that's quite a hefty task. And there are a better way to do that. So in this case, on the right-hand side, on the upper corner, you can see stock rocks allows you to triage this vulnerability and then enhance them for you. Similarly, on below that, you can see Aquasec having another vulnerability management system that allows you to do the same. You can also use tools like Qualys or Sysdig. One thing you have to bear in mind if you do the self-managed assessment of this vulnerability is you need to be able to hunt those vulnerability yourself. You need to be able to use something like Cube Hunter and then send those vulnerability or pen testing or any other way for you to get the vulnerabilities and get it assessed. And that becomes quite a lot of effort. Another thing is encryption. So obviously there are two kinds of encryption. You have the encryption at rest and encryption in transit. Encryption in transit is quite simple in Kubernetes. Kubernetes uses the PKI, public key infrastructure, internally to sign to encrypt all the requests from the API server to everywhere else in the cluster. For north-south traffic, you usually depend on a load balancer in your cloud provider. For example, if you're running AWS ALB, then usually the encryption, the TLS encryption happens there using AWS full managed services, or the same for Azure or GCP. For east-west traffic, which means from a service to service rather than from outside to inside, it becomes a little bit more tricky. So you need the ability to do TLS encryption inside the cluster. And that's usually achieved through a service mesh. And you need to be able to allow mutual TLS encryption there. So each service would have the service-to-service encryption. At rest, encryption at rest, though, it's quite a different story. So Kubernetes secrets are not encrypted by default. People tend to forget it, but just because you create a secret in Kubernetes doesn't automatically mean it's encrypted. So you need to be able to create the secret, but encrypt the secret. So how do you do that? In AWS, in Kubernetes, there are 4 ways to do this, actually. So you can use AES CBC, Circuit Box, AES GCM, or KMS. But I highly recommend that you go with KMS. One caveat to this and one pitfall is you need to do this before you create a secret. Otherwise, they're not encrypted and therefore they will be corrupted and you can't get them anymore. So if you already created a secret before you create the encryption keys, make sure that you back them up, create the encryption keys, and then restore it. Another thing you have to keep in mind is the ability for your pods to assume IAM roles or service accounts for GCP. So all pods should have the ability to, all pods should have a service account. There's 3 reasons why. Service accounts is a Kubernetes native construct, but service accounts allows you to extend or reduce pods RBAC access using the service account. This allows the use of kubeconfig inside Kubernetes. You shouldn't really need to use kubeconfig inside Kubernetes because you're using service accounts. And a good side effect of this is whenever you do Kubernetes audit logs, you can pinpoint which service accounts did what inside the audit logs. In Kubernetes and AWS, you can use KIAM, you can use IRSA or Kube2IAM to do this. Another reason why you should do this is you shouldn't really make your pod assume the node role because that is not least privilege and therefore could be a gateway to breach your cluster. Another thing you have to keep in mind is network segregation. This is especially important if you're trying to get a PCI DSS cluster in order to receive payment. So the simple requirement is you need to be able to segregate production and non-production environments. So before you do that, you need to be able to have the visibility inside your cluster. So a good tool for this is Weavescope by Weaveworks. It uses eBPF kernel modules, and you can then visualize the traffic flowing in and out of your cluster, as well as which pods connect to which pods. You can see Kubelet actually connects to the internet outbound, and it connects to core DNS, to manager, to home controller, and so on and so forth on the image on the right-hand side. And based on this, you can craft your network policies. If you're using Cilium, then you're in luck. Cilium just released a new editor, so you can see it's a little bit on the left-hand side, but it allows you to visualize which namespace has access to which namespace using the pods. Using the labels. So app equals Prometheus has access to app equals Redis, for example, using the match labels in the network policies. And network policies is how you would enforce those network enforcement. Another thing you have to bear in mind is the ability to do runtime scanning. Once your pods are running inside, once your container are running inside pods, then you need to make sure that they're still not vulnerable. So one way to do this is to run a runtime vulnerability analyzer. So an open source tool called Kubai allows you to do this. As well as you need to be able to understand if your pods are being intruded. So if somebody tries to, let's say, create a shell in one of the pods, if they're not supposed to, then you should really be alerted. So on the image from the right-hand side below, you can see I tried to get a pod, and I can see there's a pod called nginx disallowed. I tried to create a shell exec into the pod, and then get a shell, and then cut the password. And then by running Falco, another open source tool, it was detected that a shell was spawned. It should probably detect which command it run as well below these logs. You can also use full managed services like StockRox or Aqua to do this, but Falco and Sysdig as well, they're really good for runtime vulnerabilities. For managed-based images, so one of the biggest problem in running container environment is you can literally build containers from anywhere inside in the internet, and there is no easy way for you to restrict which base images your developers can use. Well, you can use policy gates, but policy gates, that's actually during the deployment process. You need to do this before the deployment process. You need to catch it early in the CI. So one thing you can do is you can create a DMZ, like your own managed base images, where you can run a bunch of scanning, you can do vulnerability tests, you can do version upgrades, and then make that as the buffer zone between the rest of the internet as well as your cluster. You need to make sure that that's done collaboratively so that the developers will have what they need, so they wouldn't need to go through the internet in order to get their base images, but rather through that hardened images. Make sure to run make sure to use container optimized OSs, and then use Scratch and multi-stage builds as much as possible to lessen the surface of attack when you're building an image. One thing that's been in the news recently is supply chain vulnerability. We all heard of the SolarWinds in the news and the supply chain issues that came out of that. So one thing you have to bear in mind when you're building a Kubernetes security in a highly regulated environment is what's your supply chain. In Kubernetes, it's going to be containers, manifests, and libraries and packages, as well as the code itself. So for manifests, we can validate those manifests if they're valid. So like you don't get like YAML bombed. You need to analyze those manifests using kubelinter or Checkov, for example, so that they're following the best practices for manifests. And then you need to be able to scan those images if needed. So for example, you can use something like Trivy or Claire and scan them. But more importantly, you need to be able to understand what libraries and packages those applications depend on. So for example, if you're running GitHub, you can run GitHub security, and then you can use Dependabot to show you if there's a vulnerability in one of the libraries your application is depending on. So more scanning. So this is actually the entry point to most of where your security posture starts. It's the registry scanning. And that's for a reason, because like most of the registries that we're using already has vulnerability scanning attached to them. So for example, ECR or key.io, they both have vulnerability scanning, but you need to ensure that this vulnerabilities actually gets triaged and sent back to the vulnerability management system. Otherwise, they won't get resolved. And it's really hard, especially since you can see there can be a lot of vulnerabilities in one image. So you have to make sure you triage them with like the high and the criticals, and then make sure that those are solved first. Another thing you have to keep in mind when you're using registry is first use a private registry like Harbor or ECR, and then use a separate registry secret per each namespace. So that means that you don't use one secret for all the namespace and for all the ECR registry, but rather use one for each namespace, and then have a convention on how you would name those repositories so that they will only be picked up by a certain secret. That's really important so that you don't accidentally use someone else's image, but at the same time, so that once you're breached, you get the defense in that authentication mechanism. When we're talking about CIS hardening, you can use Qbench, an open source tool by Aqua, to understand where in your Kubernetes you need to focus on. So sometimes it's really easy fix, like making sure that one flag or two flags or a lot of flags are not set to true or set to false. But if you're using a fully managed Kubernetes cluster like EKS, it becomes a bit more complicated. But that's also something that's supported by Qbench. So look for that as well. Another thing that usually is asked of me is, how do you do secrets management in Kubernetes? I already said that Kubernetes secrets are not encrypted by default. So it would make sense that first encrypt the secrets so that anybody who can access your etcd doesn't automatically get those secrets. But at the same time, you need to be able to do more than just create a secret. You need to be able to rotate those secrets. You need to be able to manage those secrets in a separate vault. So for example, in this case, we're using AWS Secrets Manager. AWS Secrets Manager becomes your external vault, and then you can run Kubernetes external secrets controller, which would then fetch those secrets from Secrets Manager and then assert those in your secret in the Kubernetes secret resource. That's a really good way to ensure that you have a fully hardened vault without having to need to create everything on deploy time. So when you deploy a secret, in this case, you ensure that you have a secret during runtime. So the secret management process becomes separate to your deployment process, which becomes really important when you're deploying highly critical applications. So here's an example on how you would do this. Suppose, for example, I have external secret up and running in the cluster. I can create AWS secrets using the secrets manager and then reference that to the external secret resource in the Kubernetes cluster. So all that will happen is the secret controller will take the name that I put in this definition in the manifest and then go to the secrets manager and then take that and then create the value into a secret resource in Kubernetes. So that's really nifty. You have the automation in there. So it just inject it on runtime. So you don't have to deploy it on deploy time along with your application. Lastly, you need to consider how you would do Kubernetes authentication. In EKS, you can use AWS IAM Authenticator or if you're running kops in AWS, you can do the same. However, if you're not using AWS, you can use OpenID Connect. And a really good open source tool for you to be able to use OpenID Connect is DEX. So DEX is an open source tool that allows you to connect with an identity provider using OIDC, OpenID Connect, and then return some credentials. Problem with that is it's a server-side application. So you need to create a client to be able to talk to DEX. So you can use Gangway by Heptio. You can see on the right-hand side, this is an example interface on how you do this. And then would even tell you or instruct you on how you can add your command line variables so that command line credentials, for you to authenticate in Kubernetes. It makes it really powerful because OpenID Connect has refresh tokens as well, so you can easily rotate those credentials as needed. Actually, it gets rotated each time you log in, which is really powerful. So there you go. We have built a baseline, and that is a really good way to start your journey into to Kubernetes in a highly regulated environment. So what do we do next? First, you can use this as a baseline, as a starting point for all your compliance work. You're on your first step to compliance, and make sure to automate each time you measure the compliance levels in your environment. Finally, we will do a very quick demo on how you would secure your supply chain in Kubernetes, for example. This is a Kubernetes GitOps repository. That essentially means that everything is created and deployed using GitOps. And here's an example on how you would do the supply chain management. So this is running on GitHub using GitHub Actions. So the first thing you can see is the supply chain consisted of validate, lint, and scan. So validate is just running kubal, looks at all the Kubernetes manifest, if there are valid Kubernetes manifest. The second is lint. Lint is just using kubelinter created by StockRocks to make sure that you're following best practices in Kubernetes. As you can see, it failed because it didn't follow some of the best practices. So I fixed those issues, and then I rerun it again. And then finally, I run the tree scanner. So this will give me the actual vulnerabilities in all of those images. Whether or not you need to run it here, that depends on your compliance requirement. But as much as possible, you should really ship your vulnerability scanning for images to the left so that your developer would be able to react quickly and fix them. And that's it for me. Thank you very much. And the implementation repo that you saw in the demo is in this GitHub repo. My name is Kenichi Shibata, and the obligatory we are hiring post in Compare the Market. Thank you so much, and we have 10 minutes for questions. Thank you.